This is the laboratory work 1. The physical meaning of the derivative. The concept of differential, tangential and normal acceleration. Let a material point move in a straight line, and let c equals c of t be the path traveled by the point during time, from the beginning of the movement. In the time interval from t to t plus t, the point will pass the path to the shown formula. So the average velocity for this time interval is equal to velocity vector, and it's also equal to the shown formula. If the motion is not uniform, then velocity v at a fixed t, it will change with a change in delta t, and the smaller delta t, the better it will characterize the motion of the point at time t. The velocity of a point at time t is the limit to which the average velocity tends when delta t tends to 0. So the velocity at time is determined by the equality. And please look at the presentation slide. Here you can find the shown formula. Thus, the velocity of motion at time t is the limit of the ratio of the path increment. And look at the slide to find some formulas. Over the time interval through t to the formula, to the time increment when delta t tends to 0. For example, if a material point moves according to a law, c equals gt square divided 2, the law of free fall actually, then in the same way, if we repeat the above reasoning, we can come to the concept of instantaneous acceleration. Please look at the presentation slide to find needful formula. So, the second derivative has the physical meaning of acceleration. Differential of the function. The differential of a function is the product of the derivative of the function and the increment of the differential of the argument. If the function y is differentiable at x0, then the differential and the derivative are related by the equality. The equality you can find in the slide. The analytical meaning of the differential is that the differential dy is the main part of the increment of the function. For small increments, dy can be considered as delta y. From the meaning of the differential, its important practical significance follows. Finding the differential of a function allows you to determine how much the function has changed if there have been small changes in the variable on which it depends. And you can find the example on the presentation slide. There is a cube with edge length L equals 1 meter. And this is the question. How much will the volume of the cube change if the edge length has increased by delta L equals 1 centimeters? Given that the increment of the volume of a cube function with small changes in the length of its edge argument is approximately equal to the volume differential, we get this formula, which one you can see in the slide. Well, and the first point, let us consider the mechanical meaning of the differential of a function. Let c equals f of t be the distance of a point moving in a straight line from its initial position. T is the travel time. The increment delta t is the path traveled by a point in the time interval delta t, then the differential, which one you can see in the slide. This is the path that a point would have traveled in the same time delta t, if it had maintained the velocity f of t achieved by time t. For an infinitesimal delta t, the imaginary path ds differs from the true delta s by an infinitesimal higher order relative value, delta t. If the velocity is not 0 at time t, then ds gives the approximate value of the small displacement of the point. Thus, from the point of view of mechanics, such a substitution means that we consider the movement on the considered section to be uniform. And the second point, let q be equal to q of t. is the amount of electricity flowing through the cross-section of the conductor. T is the time, delta T is a certain period of time, delta Q equal the shown formula is the amount of electricity flowing through the specified cross-section for the time interval from movement T to movement T plus delta T. Then delta Q over delta T, it is called the average current for the time interval delta T and is denoted E sub AV and the limit E. And the formula of E, which one you can find in the presentation slide. This is the current strength and at a given time, instantaneous current strength. The differential dQ equal E delta T is equal to the amount of electricity flowing through the cross-section of the conductor during the interval delta T, if the current strength would be constant and equal to the current strength at time T. And the third point, let us give an inhomogeneous rod. A rod is called homogeneous if any two sections of it of the same length have the same mass, and inhomogeneous otherwise of length L, and let m be equal m at x be the mass of a rod length x, measured from a fixed end. And the illustration you can see in the presentation slide. Please pay attention. Then the shown formula is the mass of the part of the rod bounded by the points located at the distance x and x plus delta x from the specified end respectively. The value rho AV equals delta m over delta x is the average linear density of the rod in the specified area. Then the linear density is rho and the equal formula you can find in the slide. If the density is constant, then the rod is uniform. For an arbitrary, generally speaking, inhomogeneous rod, the differential dm equal rho delta x is equal to the mass of a homogeneous rod or length delta x with the constant density rho, equal to the density of the rod under consideration at a given point. Normal and tangential acceleration. Let's talk about this too. In any case of movement, the speed is a variable value. The acceleration formula you can find in the presentation slide. Please pay attention. This is also a vector quantity. When moving in a curved direction v, it also changed in direction. Which way, you can ask me? At what velocity? Expression does not answer these questions. And please pay attention to the followed picture in the slide. We introduce a unit vector associated with point A and directed tangentially to the trajectory of the point A. Vectors r and v at the point A match. Then you can write vector velocity equals vr vector. Find the acceleration. This formula you can find in the slide. We get two terms of acceleration. Tangential acceleration is determined by the formula, which you can see in the presentation slide. Please pay attention. Where dv over dt is the rate of change of the velocity vector magnitude. Acceleration characterizes the change in the velocity vector by value. If dv over dt is greater than 0, then acceleration directed in the same direction as the vector v, so accelerated motion. If dv over dt is less than 0, then acceleration vector is directed in the opposite direction, v vector, so this is slow motion. If dv over dt is equal to 0, then acceleration vector and velocity vector are constant values, so this is motion with a constant modular velocity. And let's go next and talk about normal acceleration. The formula of normal acceleration you can see in the presentation slide. Please find it and pay attention. The rate of change in the direction of the tangent to the trajectory, dr over dt, is determined by the speed of movement of the point along the circle and the degree of curvature of the trajectories. The degree of curvature of a plane curve is characterized by curvature. And our next point is radius of curvature. R is the radius of a circle that merges with the curve at a given point on its infinitesimal section ds. And the formula of radius of curvature you can find also in the presentation slide. The centers of such circles are the centers of curvature of points O and O'. Please look at the figure number 3. The rate of the tangent direction change can be expressed as the product of the rate of change of the angle by the unit vector showing the direction of change of the angle. d tan over dt is equal to d phi over dt n, where n is a unit vector directed perpendicular to the tangent tau at a given point, so it means along the radius of curvature to the center of curvature. It follows from that d phi is equal to ds over r, but since ds is equal v dt, then df is equal v dt over r. Then d phi over dt is equal v over r, and hence d tau over dt is equal vr n. Finally, v d tau over dt is equal v square over r n. So it means the formula which one you can find in the presentation slide. Normal acceleration shows the rate of change in the direction of the velocity vector. The magnitude of normal acceleration is the module vector acceleration, which one you can find again in the slide. The term centripetal acceleration is used when motion occurs in a circle. If the motion follows an arbitrary curve, then the corresponding analog is the term normal acceleration, perpendicular to the tangent at any point of the trajectory. So, returning to expression, we can write that the total acceleration vector for moving a point along a plane curve is a formula of acceleration vector. And figure 4 is showing the relative position of the acceleration vectors. Please pay attention. As can be seen from this figure, the total acceleration modulus is, and this is the formula, please find it. Let's consider a few limiting special cases. The first case are when uniform rectilinear movement. The second one are when equidistant rectilinear motion. The third one are when uniform movement around the circle. And that's all for today. Thank you for your attention.